Okay, so we're beginning a new chapter, Chapter 8, Statistics, Section 1, Collecting Data. Before I get into this first section, I just want to talk a little bit about how this chapter fits into the grand scheme of our course. So in the beginning, we started with Chapter 2, which was set theory, and that tied in pretty nicely into probability. We didn't do too much with it, but if you go on to take more probability or statistics courses, you'll find that set theory stuff to be very helpful. Then we talked about the logic, right? Chapter 3, logic statements, and that was kind of a standalone chapter in a way. Still helpful though. Maybe harder to make an argument for how it's helpful in your everyday life. Then we had chapter 4, right, which was kind of that real life math, proportions, percentages, ratios, stuff like that. And then chapter 6 was geometry, another standalone section, but still very useful in real life. And then we had probability, and probability is going to tie nicely into statistics. Maybe not so much for us, because for our purposes, we're only going to talk about collecting data, which is section 1, displaying data in section 2, and which means graphs, and analyzing data, so measures of center and different things in section 3. So we're not going to dive real deep into stats and probability. We're just kind of getting like an intro to each section or to each subject, but they're very much interrelated in that statistics is, if you were to boil it down, it's kind of like a theory of information. It's all about data. It's all about collecting data, displaying data, and analyzing data for the purpose of making some kind of inference. And probability is about, you've already got the data, right? So in all the problems that I gave in in chapter 7, I just gave you some data and asked you to measure the likelihood of a future event, right? So they're very much interconnected by that idea of having data, either statistics, you're collecting the data and trying to make inferences from the data that you have, and you can see how probability is very much going to be related there, because probability is one of the ways we can measure the likelihood of a future event. Okay, so let's get into 8.1, which is collecting data. So in this, we're going to be talking about, well, it's going to be a lot of definitions, different ways of collecting data from a population. I'm going to be following along the way the text goes here. This is on page 371. And the first definition we see is a population. So let's just get that written down. So a population is a particular group of interest in a study. Okay, so this is going to be the broader group that we're looking at whenever we're doing one of these problems. Group of interest. One of these collecting data problems. So the example the book gives, I think it's pretty good. We can all relate to this. Let's say you wanted to consider which car gets the best gas mileage. So you may naively define your population to be all vehicles, right? But maybe that is a bit too broad, because maybe the car that had the best gas mileage, they say, was only available in Romania 20 years ago. So obviously that's not going to be feasible for someone in the US to get a hold of a car like that. And even if you did, getting it transported here and everything would probably end up costing more than you would save with its good gas mileage. So you can restrict the scope of your population, and they say, how about narrowing your scope of interest for this population for the car with the best gas mileage to all passenger cars manufactured in the United States in 2013. Okay, and that seems like a much better thing to measure, a better group to measure, because we're in the United States, and 2013 is I'm assuming this book was published maybe in 2013, maybe that's why they picked that year. That year would depend on how much money you wanted to spend. If you're looking for a new car, you would say 2020, right? And you can never have your population being too narrow, unless you should always try to make your population as narrow as possible when you're picking a population, because the less extraneous data points you have in your population, the easier it is going to be to analyze and display your data later. So, say we have a good population, some more vocab words coming now. Data is just the information collected for a study. I'm not going to write that down. I feel like we all know what data is. A census, though, that's an important one to note. A census involves collecting data from every member of the population. So this is like the best case scenario, from every member of the population. If you can get a census, in our case, describing a car with the best gas mileage from the U.S. in 2013, that would be if you could find the data measuring the gas mileage of every single car in the U.S. that was manufactured in 2013. And that's like the best case scenario, right? You have all the data, you don't have to make any inferences or anything, you've got all the data. That's called a census. A parameter is just some measure of the data. It could be all sorts of things. It's some numerical measure or description. Is the numerical description of a particular population characteristic. Population. So you give some kind of characteristic of the population that can be measured numerically, meaning with a number, and that's a population parameter. We can just say a parameter for short, but the most correct way of saying it is a population parameter. So obviously, for the example I've been talking about with the gas mileage of cars, an obvious population parameter would be that actual gas mileage. That would be like the most important thing, right, that we want to measure for that population. Okay, so I said a census is the best way to get data, right? Like if you can just measure every single car's gas mileage in the U.S. in 2013, then that would be ideal. But often you cannot do that just because it just depends on what you're measuring. Maybe you can't get the data for every single item in the population. So if that's the case, you've got to select a smaller subset using the lingo from Chapter 2, a subset of the population called a sample. So a sample is just a subset of a population. And just like we had a population parameter, which was some numerical description of some characteristic of the population, the corresponding term for a sample is a sample statistic. A sample statistic. These are just fancy phrases. Statistic. and you'll see it's the exact same definition is the numerical description of a characteristic of a sample. Okay. Okay, so we've got a sample being a subset of a population, so you've got the broader population of cars manufactured in 2013. Maybe a sample would be shrinking down to just cars in Alabama, available in Alabama, and a sample statistic might be just the gas mileage, the average gas mileage for cars in Alabama. And even though that's describing the same characteristic, average gas mileage, it will be different probably than the corresponding population parameter. Right? So, for instance, here's another example. I want to just make sure it's understood that though these describe the same things, they describe them for different groups. A population parameter is a much broader, well, population is a much broader group, right? So as another example, consider the population of, let's see. Okay, so consider the population of people that live in the Middle East. Okay, so billions of people, right, living in the Middle East. And we want to have a population parameter that is going to be the number of people that speak, Okay, let's say the number of people that speak Turkish. Okay, so we would have some number, who probably just very close to the population of Turkey, right? Now, I don't know if they speak Turkish elsewhere, but anyways, what if we picked a sample, so a subset of the population, and the sample we just zoomed in on some other country, right? Iran, right? Where maybe not as many people speak Turkish, right? So we measure the sample statistic, the same description, so number of people that speak Turkish, and we would find it to be much lower. So the population parameter and the sample statistic, even if they're measuring the same thing, will probably not be equal. Okay. There's a nice little table, Table 1 on page 372, that describes some differences between population and sample. And the thing I was just pointing out is that the statistics vary with the sample chosen, right? So you can drastically change your sample statistics just depending on what your chosen sample is. So let's consider example 1, which is just going to walk through a description of a couple surveys that were given. So a survey is just a way to collect data. And we'll talk about what is the population that they're measuring, what is the sample that they're actually looking at, and what are the population parameters or sample statistics in these surveys. So part A says, a headline about the rising obesity among young people led a school board to survey local high school students. Okay, so right off the bat, I'm saying that they are surveying local high school students. Now, am I sure whether that's my population or my sample yet? It's probably the population, right? Because are they going to be able to survey every single high school student? Probably not, but let's read on and see. Out of 231 students surveyed, 58% reported eating a high-fat snack at least 4 times a week. Okay, so there we see they did not survey every single student. So that means my population, the broader population that I'm trying to make inferences about, is high school students. But really, this is a headline in some city, so it's not just high school students across the U.S., right? It's whatever the city is, we'll just say local high school students. If we had been given a city or a district name, then we could put that, but they were vague about it, so we can just say local high school students as they did. Okay, our sample is going to be that smaller subset of the population that was actually surveyed here. So the 231 students. They didn't tell us how they got these students, where they're from. Maybe they're all from one school. Maybe they were randomly selected. We'll talk about different ways of pulling a sample from a population right after this example, actually. Okay. And the results, what do they want? They want the results of the sample. Are they a sample statistic or a population parameter? Well, the result is a sample statistic because it only deals with the students who were surveyed, right? So how do I know that? Well, it says out of the students surveyed, right? And then they give the result of the 58%. So since the result only applies to those in the sample, it's a sample statistic. Okay. Okay, part B says a nonprofit organization interviewed 618 adult shoppers at malls across Louisiana about their views on obesity in youths. Okay, the resulting report stated that an estimated 48% of Louisiana adults are in favor of government regulation of high-fat fast food options. Okay, so let's try to parse this statement. First of all, it starts off saying a nonprofit organization. Okay, is that part really important? Is that the population or maybe the sample? No, that's just the group that conducted this survey. So for us, that's not really, for what we're trying to do in this problem, not important. Okay, they do say they interviewed 618 adult shoppers at malls across Louisiana. Okay, that tells me that the population is adults in Louisiana, not just people who shop in malls. That's just where they conducted their survey. So that would mean my sample would be the people who were surveyed in the malls. Okay, so the broader population is adults in Louisiana. That's what we have to pull from this. The broader, how do you spell Louisiana? Okay. The broader population that they're surveying, the group that this sample belongs to in a broader sense. Okay, so the sample, that smaller group that belongs to adults in Louisiana, is the people who were surveyed in the mall, which was the 618. I should say adults because they are pointing out that they're adults. It's implied if my population is adults, then the people who are surveyed should also be adults. 618 adults surveyed in the malls. So you may think, based off of this sample, you may say, well, is this really a good representative sample of everyone in Louisiana? And that's a good question. Are the adults who shop in malls necessarily going to be a good representative sample for every adult in Louisiana? Maybe not. But despite that, they still make a claim. The actual result is that an estimated 48% of Louisiana adults are in favor of government regulation of these high-fat fast food options. Okay, so is their report or their result about these people who were surveyed in the malls? No, it doesn't say that. It does not say out of the 618 adult shoppers, 48% want this government regulation. It says the resulting report, so they're talking about the report they got from these people, but they're not telling us what the data is. They say the resulting report gives an estimate of 48%. So what they're doing is they're taking the data they got here, in this sample. They're not telling us what it is, but we're probably to assume that 48% of them were in favor of government regulation. But then they're taking that sample statistic and applying it to the entire population, because they're saying an estimated 48% of the adults in Louisiana are in favor. So the result is a population parameter. They're making an inference from their sample statistic to get a population parameter. Okay. Okay, so one of the things I pointed out in this is that this may not have been a good sample. I mean, you may also have issues with them, saying that the result they got from their sample can be blown up to be an estimate for the entire population, and I think that's a legitimate concern, but wouldn't that concern just come back to this sample not being representative of all adults in Louisiana? So we need to talk about how to choose a sample and the different ways of choosing a sample, and when one type of way of choosing a sample might be better for certain situations than others. So let's talk about choosing samples, or choosing a good representative sample for a population. For a given population. So that's going to be the topic that we get into now. Okay. Well, first of all, a representative sample, which I've been throwing that word around, or that term around already. The book tells us that it is one. Let me read the full thing. A representative sample is one that has the same relevant characteristics as the population and does not favor one group of the population over another. Okay, so looking back at our example here, we may say, this does not seem like a representative sample because I can't imagine that all adults in Louisiana shop in malls, and maybe the people who shop in malls just have a different view than the population of adults in Louisiana as a whole. So a representative sample, as a definition, it just means what it sounds like. It should represent the given population. And how does it represent the given population? It should share the same characteristics that you care about measuring with the population. So phrased another way, it should not favor one group in the population over another. Okay, so I'm going to, instead of just writing down these definitions, because we've got 4 or 5 coming up, different types of sampling, instead of just writing them and discussing, what I'm going to do is I'm going to give you a picture. I'm still going to read it and discuss it, but I'm going to give you a picture of what each one of these might look like. So first, let's start with random sampling. Random sampling. Okay, so it tells us it's what it sounds like. A random sample is one in which every member of the population has an equal chance of being selected, meaning they're done at random. So say I have 15 data points, we'll just make them literal points just to be arbitrary. They could be numbers, letters, whatever, people's names, who cares? So it's just random data points. A random sampling would be where I just do my best to just say I want to select 5 of these points. I would just do my best to just kind of randomly go around and select 5 data points. Okay. So maybe this seems like a pretty good way to represent a population. Something we should note, though, is you should never really trust a human being to randomly pick things, okay? Because we are not wired to randomly pick things. We like to pick things in some kind of pattern. The book actually gives a cool little example where they say, choose 3 random digits between 0 and 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Choose 3 digits. Now once you have them, try to answer those questions on the top of page 374. And it says, if any reasons influenced your choice of digits, then your sample is not random. So that's just one small example of why maybe a random sampling may not be the best. If you've got one person in charge of randomly selecting, then maybe that's not going to actually be a random sample. But a true random sample, in most cases, well, it depends on the situation, but a true random sample, maybe generated by a computer, should be good. Alright, the next type of sampling is stratified sampling, and this definitely probably not familiar to you. It is very intuitive, though. A stratified sample is one in which the members of the population are divided into 2 or more subgroups, each called strata, that share similar characteristics like age, gender, or ethnicity. A random sample from each stratum is then drawn. So strata is the name of each group, and stratum is the plural of that. Okay, so if I was going to do that here with my dots example, so say I take my 15 dots and I split them into 5 stratum, so each one of these is a strata of size 3 elements in each. And I want to pick five elements, then I would just randomly select one from each stratum, or from each strata. It's important that each one of these little subgroups is itself representative of the entire population, meaning I should not group these into groups based off of their characteristics. They should all be random groups. So the way they should be split up depends on what kind of problem you're trying to solve. So the example given in the textbook is freshmen, sophomores, juniors, and seniors. So, probably each one of those groups would not lean more heavily towards one ethnicity or another or something like that. So that would be, depending on what you were doing, would be a good judge of, or a good representative sample, or a way to split up the population. What is one way where their example would not be good? Well, what if you were trying to... Okay, I've got it. So what if we were trying to measure something about freshmen in particular? Then we would not want to use this kind of stratified sampling that they've drawn out here in the text, because that would include people from other years, sophomores, juniors, and seniors, right? So if we just wanted to identify just the group of freshmen, then that would be our population, and maybe we could use some other kind of stratified sampling within that group. Okay, cluster sampling is next. Cluster sampling. Okay, a cluster sample is one chosen by dividing the population into groups, just like a stratified sample, called clusters that are each similar to the entire population. The researcher then randomly selects some of the clusters. The sample consists of the data collected from every member of each cluster selected. So you can see that this, while similar at first to stratified sampling, is different because once you split them into groups, you don't take one piece or just a few pieces from each group to create a new group. You just select an entire group, and that's the sample that you measure. So maybe I take my 15 dots here and I split them into 3 groups. Each one should be representative of the whole group as a whole. And then instead of selecting elements from each one like I would do for a stratified sample, I would just select the entire group. and then just measure this as my sample. So the example they give in the text is, let's say, where is it? For instance, if you wanted to know the average grade on the first test of all students in English 101, there's already kind of a natural way to divide them, right? You could divide the students up by the sections they are in. So they say English 101, Tuesday, Thursday at 10:15 a.m., then the 8 a.m., 12 p.m., and 2:30 p.m. For each cluster sampling, you would then randomly choose several sections and collect grades from all students in each of those sections that you chose. I think that maybe is not the best idea. Surely the grades in the 8 a.m. class versus the 2:30 class, there may be some difference there because of the time of day, right? That might be an interesting thing to actually measure too. So look at those two groups and see if the 8 a.m. class suffers from it being so early, right? So maybe clustering that way, you would need to be careful not to just pick early classes, because that might skew your data and make you think something that may not be true about the population as a whole. Okay. Systematic sampling is next. A systematic sample is one chosen by selecting every nth member of the population. Okay, it's not a random sample. It's you pick some number n, depending on how large your population is and how large you want your sample size to be, and you just select every nth member. So for my example, if I had my population being these 15 dots, and I want to end up with a group of 5, then I would pick every third dot. So the n, so when they say chosen by selecting every nth member, for me that n is 3. And that just depends, again, it depends on how big your population is and how big you want your sample size to be. So since I want 5 elements in my sample, I need to pick every third one because there are 15 total. So I would pick this one, then this one, and this one, and this one, and this one. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This would be my systematic sample. Okay, so the last type of sampling, probably the worst kind, is convenience sampling, so named because it is convenient for whoever's conducting the research or the study or the survey. So a convenience sample is one in which the sample is convenient to select. Yeah, okay. That's pretty much implied from the name of it. So how could I draw? I'm going to have a hard time drawing this with my example. Okay, so maybe I'll say if I just had 15 dots here and I wanted to select 5, the fastest way would be, for me to just select the first 5. It's convenient, right? It's also maybe not the best way to select a representative sample. So the only argument the book really makes for this type of sampling is some is better than none. Okay, so they say, although convenient sampling is the least reliable for obtaining a representative sample, in some instances it is all the data we can obtain, and the sum is better than none factor comes into play. So, in other words, if this is the only way you can get your data and it's either this or nothing, then this is it, right? So this is clearly the worst way of sampling your data. Okay, let's go through an example where we just identify the type of sampling to be used, or that is being used. Okay, so to conduct a survey on collegiate social life, you knock on every 5th dorm room door on campus. So I think this one is pretty clear because they say every 5th dorm room door. That's going to be that sampling technique where you're picking every nth number or nth member of the population, which is systematic. Alright. So the key to that one is that every fifth dorm room door. Okay. Student ID numbers are randomly selected from a computer printout for free tickets to the championship game. Okay. Well, they use the word random there, so I think random sampling, yes. That's it. If you really wanted to be particular, you could say, because it should be that every student has an equal chance of being selected, then it's a random sampling. Fourth grade reading levels across the country were analyzed by the school board by randomly selecting 25 fourth graders from each school in the county district. Now they say random selection, but it's not a random sampling because the students are randomly selected from groups, a smaller group, the small group being each school in the county's district. So when things are randomly selected from smaller subgroups, that's a stratified sample. Okay. Oops. So part B, I said, was definitely random because they said they were randomly selected, but that's because there was no mention of any kind of like subgroups of these ID numbers being created, right? It's just all of the ID numbers are on a computer printout and then they're randomly selected. So there's no subgroups being made, which is why this one was not stratified sampling. In order to determine what ice cream flavors would sell best, a grocery store polls shoppers that are in the frozen foods section. Okay. So the store did not take shoppers, split them into groups, and then randomly select, or they didn't do any groups at all, so it's not stratified or cluster sampling. And it's definitely not random sampling because they're doing they're surveying people in their store in the frozen foods section. So it must be convenience sampling. And when you think about it, this really is convenience sampling because they're surveying people in their store. It's very convenient for them to do, right? They don't have to go anywhere. They don't have to send out a survey or anything like that. They can literally just walk around their store in the frozen food section and poll the shoppers that are there. And in this case, this would be good, I think, for convenience sampling because this store is going to care not really about the general population, but the people who shop at their store, right? So convenience sampling, and even more so, maybe not such a bad use of convenience sampling. To determine the average number of cars per household, each household in 4 of the 20 local counties were sent a survey regarding car ownership. So we have to look at how they did this survey here. There are 20 counties, and they picked 4 of those counties. Okay, so we see there's some grouping going on here, so we're thinking either stratified or cluster. And what they did is they split into those 20 natural groups, the 20 counties being those groups, and then they selected 4 of the groups, and they sent every single person or every single household in those 4 groups a survey. So that's definitely cluster sampling, right? That's definitely cluster sampling. Stratified sampling would be where you took those 20 groups, those 20 counties, and selected people or households from each county and made a new group of random people from different counties. But it's cluster sampling because they didn't do that. They split into groups, and then they just selected 4 of those groups and sent every single household in each of those groups a survey. Alright, so that's all the examples from the section, But I want to, there were no examples in the text asking you to provide the appropriate type of sampling method. So I want to go through at least one or two homework problems from the text in numbers 21 through 24. Because this little part of the homework says determine an appropriate sampling method for each scenario. So I did an example with you where they gave us a sampling technique and we identified it, but now I want to do another example. I'll just call it example 3, where we try to decide what type of sampling is most appropriate. Okay. And also they say to describe any potential biases that the researcher might need to consider. A state senator, so I'm doing number 21 here. Let's see if this is a good one. A state senator wishes to survey his constituents on issues in the upcoming legislature session. Okay. So right off the bat, you might be thinking a random sampling. I think that would be okay here. So the thing with this is there's going to be multiple answers, okay? But if you give an answer, you should be able to defend it. So I think random sampling would be okay. Random sampling would be okay, and what else would be okay? Maybe stratified sampling. So let me back up here. Random sampling might be okay because we can just randomly select maybe, I don't know how many constituents this senator has, but we can randomly sample some portion of them just by selecting random people from around in his area. Okay, and hopefully that would be a good representation. Now, what if we did stratified sampling? Well, we could just look at maybe the natural divisions in his area, or his or her area. Oh no, it is a his. Okay, his area where maybe there are like district lines or city lines or something like that, and we could randomly pull from each one of those places. Now, that may not be good if there is one giant district and one tiny district, and those are our two subgroups, and we pull 50 people from each group. That would not be representative of the area as a whole, because this district is much smaller, right? So we would have to be careful with our stratified sampling. What else would be appropriate? There's cluster sampling, but we could cluster by picking just one district or maybe a couple districts, but that's probably not a good idea because the people living in different areas are going to have different, they're going to be worried about different issues. Convenience sampling is probably not going to be good. It's pretty much never good, right? So I think these are the two best answers here, either stratified or random. All right, let's look at So let's consider number 22 now. It says a pharmaceutical company wishes to test the outcomes of a new drug for a particular skin disease, and they found 1,200 patients willing to participate, but they can only choose 100 of them for the actual study. So their population is the 1,200 people, and they need to make a sample of 100 people. Random sampling, again, sounds good here. Just randomly have a computer randomly select 100 people. Maybe systematic sampling. They could pick every 12th person. I think that would be okay here too. Systematic sampling. Stratified sampling may not be so good here because it might be harder to make there's no natural way to make the groups here. I suppose we could just create 12 groups and and select 10 people randomly from each group. That might be okay too, yeah. It just seems, stratified sampling seems less natural to me here because there's not a natural way to split these patients because we don't know anything about them. right? If we knew they're like age groups, maybe we could split them into age groups and then pick randomly from a certain number from each age group, or ethnicity, or something, something to do maybe with the drug. It's for a skin disease, so maybe we would want to sort them into different skin tone groups and then randomly select from each of those groups, but we don't have any information about that. So I don't think stratified sampling would be one of the best answers here. And kind of same goes for cluster sampling, because again, there's no natural way to make the groups. And convenience sampling is kind of not really relevant here. And even if there was a relevant way to make it apparent in this study, like they could pick the first 100 people that volunteered, it probably would not be a good representative sample. Did I miss any? Did I not talk about any that we should mention? Systematic. I already got systematic. Okay, yeah. I think systematic would be okay here too. Okay, good. So that is it for 8.1. That is collecting data, and in the next section we'll talk about displaying data, so graphs.